move this bar. Okay. Somewhere. Yeah. Yeah, I will start with the basic commands. So Birgitte has shown several commands, yes, in Git. And I will go in detail on all these commands and other commands as well. So Birgitte just showed that to test if your Git installation was working well. But now I will go in detail. Let me see. Okay. Yes. So is the size of the presentation okay, or should I increase it? And also, this is the terminal that I will use at the bottom. So if the font size is not good, let me know. I will check the chat. Okay. Yes, it's okay. Okay, thank you. Yes, I will continue. So the first command that we will look at is the help command. So this is useful because in this case, you can get the help of Git commands in detail, right? And there are at least two options I know to get information from the Git commands. The first one is by typing git help, yeah, and the name of the command. For instance, here I have my Git installation in my local machine. Then if I type git help and some command, for instance, commit, then I will get the detailed information of this command, right? And all the options that it can use and the explanation of all these options. So if you want to increase the scope of some commands, then you can add some of these flags. And another way to get help is by typing man, and this will work in Linux, or if you have some terminal emulator, yes, right, in Windows or Mac that supports this Git, these man pages. If I am in Mac and I type, for instance, man git and the name of the command, for instance, git commit, then I will get the same information, right? But in Windows, it would depend on what type of installation you did for the terminal emulator. So this is available on Mac and Linux in general, but in Windows, it may depend. But if you type git help and the name of the command, then it should work in all these operating systems. So this is the first starting point for Git, and if you want to know more about some command, then these are two possible options. So the first thing that we need to do, yes, in order to use Git, is to create a repository. And this can be done in several ways, right? The first one is if you start your repository from scratch. So if you have a new project, right, and you want to get started with it and get started tracking the changes with Git, then this is the first thing that you need to do. So here I am in this terminal emulator, right? And it is a Mac computer. It supports Linux commands. So I can type here pwd, and this will show me the location of the current directory, right? And here I want to start from scratch with a project called My Project. So then I can type mkdir, My Project, right? So this will create a folder. And if I do cd, My Project, then I will move to this directory. So if you work on Windows only and you don't know Linux, then you can create a folder as usual by using the mouse button, and then you can move to this folder with some command like a cd, right, on the terminal. And now I am inside this folder, right? And the first thing that I need to do is type the git init command. So, and as it says here, this is an empty Git repository, and Birgitte mentioned previously that Git creates a folder called .git, where Git will store all the files that are required by Git. So the content of this folder will be mentioned later on. So, but briefly, if you type ls.git, so you will see that several folders are created, including head, config, description, hooks, info, objects, reft. So they will be described in more detail later on in this course. So basically, this is the difference between a standard folder for your project and a Git project. This will contain all the information for your project development. And Git will track all the changes and store them in this folder here. Okay, so we have initialized our repository, right, with the git init command. And then we can ask about the status of the repository. And see, there is one question. There is a question, how can we list in Windows? I think you mean the list, the files. If that is the case, then in Windows you can use dir, D-I-R, and it will list the files. Okay. Now we can ask about the status of the repository that we just created. And here we can type git status, right? So it tells us we are on the branch called main, right? And no commits yet. So we haven't committed anything. And there is also nothing to commit because we haven't created anything. Notice here that I'm using a relatively recent version of Git where the main branch is called main. But if you are using a older or much older version of Git, you will see this message on branch master because before it was called master and now it's being called main. So you can also rename the master branch to the main branch, as Birgitte mentioned in her lecture. So basically, this repository is now empty, and we can start adding some files to it. Let me move on. So we have seen now how to create, right, a repository from scratch. But what about if we have some existing repository in some location, right? So here there is the location of our repository, and it may be located in some GitHub platform, GitLab, maybe Bitbucket, or even some of your colleagues set a repository in a local server, right? So maybe your department, some person has some code and it's already available on a local server. And then you can clone it, right? So get a copy of that repository in your local machine. So how do you do that? So you type git clone, and then the repository location, right? Which can be a URL if it is online, or the path to that folder in your local server. And then you type the path where it will be located. So how does it work? So here, for instance, I have some existing repository, right? That is online and it is on GitHub, right? And I want to put it in the current folder, right? In a folder called my project. Notice here, my dash project. So how can I do it? So I move out one directory above the current one. So I can now see that I am located in the same documents folder where I was before, because otherwise, if I type git clone and I was still sitting in my project, I will clone this repository inside my previous project, which was my project. So now here in this current directory, I can clone my repository, GitHub.com, Alice user 2020, my first project, and I will call it my first project. okay? So it's cloning, right? And it tells you information about the objects, yes, that they were fetched. And now if you look at the content of this folder with the command ls, you can see that the new first clone project is here. So then you can move to the folder containing this cloned project. First project. So if you want to complete the line, so if you are in Linux and you want to complete it in a faster way, you write some characters, yes, from the name, and then you press tab, and then it will complete the characters. So now I am inside the clone project, and here I can type the git status, and you see that in this case, because it was an old a project that I set with an old version of Git. Now the main branch is called master, and also there is nothing to commit, right, at this point. So, and here there is a picture that shows the behavior of the Git commands. And I think that it can be useful to you, yes, so that you understand what the Git commands or the most common Git commands are doing, and how the files are moving around, yes, between the different folders that are used by Git. So it may be a bit complex at the first sight, but it will be more clear during this course, I hope. And later on, if you want, you can take a look at this picture and see, and maybe this can be helpful for you even after the course. Well, let me explain briefly what is this picture about. So we have seen how to set a repository from scratch, right, with a git init, or by cloning the repository with the git clone command. So basically, if we do this initial setting, you will get a local repository, which is enclosed in this folder here, right? So here in this local repository, Git will work with different types of file stages, right? And they are depicted in with these smaller folders in different colors. And we can distinguish, for instance, the working directory, the index that is called staging area. Yes, they are synonyms. We can distinguish also the local branches, and one can separate this in local branches, right? And the local copy of the remote branches. So we won't see this one until we deal with the remotes in one of the coming lectures, right? So we can't forget about this one for this lecture today. So basically, before we talk about the remotes, we will be dealing with the files in this area, right? And just when we talk about the remotes later on, then we will include this part here. So notice what we did. With git clone, we get some repository, right, from outside, and then we put it here in the working directory. And here you can see how the git commands work. We will explore them in detail right now. And this can help you later on to monitor the behavior of the files and how they are moving around. So if we want to see the difference or the changes in the files, we can use the git diff command, and git diff supports different options. So it can monitor the difference of the files that are in different stages, either here between these two, right? The working directory and the staging, and also between the working directory and the local branches, and so on. So here there is some basic schematics on how the git diff works. So let me go to some first modification, right? So now I am sitting in the clone repository, right? So, but I will move to the one that I created from scratch, which was my project, right? So I type the git status, and remember that in this repository, I didn't put any file, any modification, so it's an empty repository. So let me create a file called first.txt. TXT, and you can do it in several ways. You can open a notepad, right, and create your file called first.txt, or you can use a Nano or a VIM. But in this case, because I'm sitting in a Linux like OS, I can use the echo command. This is my first file. Yeah. And then I will send this output from echo to a file called first.txt, right? So this will create a file called first.txt, and the content of this file can be seen with either VIM or Nano or Notepad. So if you are working on a terminal emulator that doesn't support echo, then you can open Notepad or some editor that you have, and then write some line like this one, right? This is the first file, and then save it. So you can take a look at the content of this file here with VIM in this case. You see that this is the line that wrote. So now I have this change in the repository because this file was not there, right? Now I can type git status. Yeah, and you see that now there are some untracked files, which means untracked means that Git hasn't seen this file before, right? And we can do several things like adding the file and committing. So we will see that right now. So what we did up to this point. So we didn't have the file called first txt. We open our editor and put some modification to this file, save it, and now we have it in the working directory, right? This is the part that we are placed up to this point. You will see what is the difference between the working directory and the staging and the local branches in a moment. So, okay, file.txt is in our working directory. And now we can add the first.txt file to the staging area. So how do we do it? So we type git add and first.txt, right? And enter. Then we check status. And it tells us there are changes to be committed. And notice here that it proposes the command git rm -- cached and the file to be unstaged. So this is what we did with the git add. So we move first.txt to the index staging area. So this is like a preparation area before you make some permanent modification, right? That you want to keep track. So this is like a waiting place, yes, so that this file is not yet ready to be placed in the Git repository. So you can still make several modifications. So notice here that after staging the file, we can still unstage it and put the file in the working directory. So Git, in this case, is suggesting the following command, git rm -- cached and the name of the file to unstage. So it will move the file again back to the working directory. So, and Git suggests this command because it's brand new and nothing has been committed yet, right? So you will see that once we start committing, then the command suggested by Git will change. So we can now type a git commit. And this will open the default editor in your system. So in my case, I'm using VIM, right? That's why it opens this type of window here. And here I can start writing. If I press I, right, it will go to the insert mode. But if you are using a default editor other than the VIM, this behavior will look different. Yeah? So here I can start typing, and I will type information for this commit. I will write, for instance, first commit in the repository. And in the commit message, you will put the relevant information for the commit. And I will mention several suggestions later on. Then I will save and close this file. And here you see the response from Git. It tells you some particular options, like for instance, because I haven't set here my username and also the email, so Git will use some default name that it gets from the account, right? So it will not match your information. So I can do it. To avoid this message. And if you take a look at the changes in this repository, you can see that with the git log command, you can see that if I don't set the username and the email address, it will get some username that is set in my account, right? And some address that it tries to get from the system. So that's why we asked you before to set your username and also your email. By this. And in the next commit, you will see a difference with respect to the previous one with the default options. So I can check again the status. And you see I am in the branch main and nothing needs to be committed. So this is the terminal VIM, right? And here you write the commit message. But as I said before, if you are using a different editor, the behavior will look differently. So we are at this point. We have committed our changes. And the status is nothing to be committed. So sometimes you want to write a short commit, or you don't need to wait a lot of time, yes, to open the VIM editor or Notepad or Nano, for instance, because the commit message that you will write is very short. So maybe this is a lazy option, right? Because in general, you need a insightful commit or detailed commit, and then you would need the editor window. But if you want to write a short commit message, then there is an option with the -m, right? And complemented with the -a. And here in these quotes, you write the message that you want to write. So this will avoid opening the window for the text editor. So what have we done with the git commit command? So we move the file from the staging area, right, from the waiting area to the local branches. So now the file is here and it's already in the Git repository. So this is the action of the git commit command. Is there any question at this point? So let me check the document. Okay, so yes, we will go to unstaging files modifications. In this case, I will cover a different aspect. So imagine that after doing the first commit for first, you modify this file and stage it. So for instance, with git add, if you check the status, the output will be, and here is the output that I got. So here I will do some modification. This is the first file, and I will write my second line. So I did a modification and check the status. So it says that there is some modified file, right? And here Git is clever and it proposes some options to do. So for instance, you can add the file or git restore to discard the changes in the working directory. So I can type a git add to stage the changes and check the status. And notice here that the Git proposed a different command for unstaging. If you remember the previous one, it was git restart. Let me see. It was git rm -- cached, and now it's git restore -- stage. And this is because now we have committed something, right? So previously, for versions before 2.23, the status would look like this, with git reset head and the file name. So if you have this version, you will see this behavior. So git suggest this command because now we have a head pointer. Yes, we have committed something, and that's why it changed the suggested option. So there is also a file here in the latest versions. We have this git restore -- stage and the file name. And there is a note from the git scm.com documentation page. And it says this command is experimental and this behavior may change. So this has been for quite a while. And so as I mentioned already, there is also the git reset head file name, and this is an old command for unstaging. And this one, the git arrange -- cache file name, was suggested by Git before because we didn't have anything to commit. But if we use that in our committed file, this command will untrack the file name, right? And leave the file in the working directory. So this is the effect of this git rm -- cache command in our file that is already tracked by Git. So this is a different behavior for all these three commands. So what to add to a commit message? So here there are some recommendations that I took from the Git course of good book. And here, for instance, we can write while this change is needed, how the problem is approached, are there side effects? Some people recommend to use 70 characters for the width of the commit message. And also a nice feature is that you can include some ticket numbers. For instance, if you type dash and some number here, this will be related to some issue in your Git repository that we will see later on when we talk about the remotes. And then when you click on this number in the GitHub repository, then you will be sent to that particular commit message. So there are many more recommendations, but these are just a few of them. So is there any question at this point? So there is a question, do I need to add again after the file modification isn't commit enough? No, you need to add the file. So as I mentioned previously in this picture, so with adding, you put the message, right, the changes into the staging area, and here you can do the commit, right? So you need to add the files first. Is there any question? Could you follow these lines? Is your Git repository or your Git installation working well? Because you will need them for the rest of the course. So maybe let me see how is this. Maybe you can give me some reaction if you could follow this presentation. And if your Git installation is working. So just give me thumbs up. Okay, I see many. Well, a few of them. So what about the others? Okay, so I will go through. Let me see. Okay, so I will go through one more slide. So if this is not clear, or if you want me to repeat something, please let me know. So reverting to a previous commit. So maybe you did some commit, right? And you regret it later. So one way to revert it is by using the git revert head, right? So we can type it here. With the git log, we will see the commits that we have done, right? In this case, just the first commit in this repository. We can take a look at git status. So now there is this change to be done that I did previously when I added the second line, and I will commit it. I will write a short message, and that's why I don't need to open the terminal window, and I will type it second commit. So if I take a look at git log, now you see that my name is here in capitals in the first letter, and also this is my email address. And previously it was like this, right? And also some default email address that Git took from the system. So the status is nothing to be committed, right? So, and Git log tells me about these two commits that I did. So if I want to revert the changes to the previous commit, I can type git revert and head, right? And it's telling me that it will revert the second commit. So then I can save this message, and then I can take a look at the log file. You can see that there is some reverted commit. So if I take a look at the file, you will see that it doesn't contain the second line that I added in the second commit. So that's why it says it reverted the commit, right? So the changes in the second commit that I did are not present, and they are just the commits from the previous message that I wrote, the previous commit. Is this clear? Is there any questions at this point? Okay. Do you have any issues with the writing the commits with your editor, or is it okay? So you can type it on the Q&A document so I can see it.
I have a question.
Yes, please.
So when you revert, so I added 3 files, 3 different commits, and now I reverted, so now I only see 2 files. Because I went back a previous one. But is there like a tree structure you can see that you like deviated, then you moved back in the commits, or?
There is a ref log command that we will explore later on, and there you will see where you are placed, if that is what you mean, or
Yeah, just so I know that I'm actually not in the head anymore, like, or I'm in there's something, because I went back, and I guess I can go forward again, right?
yeah. So this is a you can do it with the ref log, but if you take a look at, let me see here, with the git log, you can already see that the head is pointing to the main branch. So you are still on the main. So the revert advances the head.
Mm-hmm.
Yeah.
But my third file is still somewhere in my my .git folder, like the information.
Yeah. So it's in the previous commit.
Okay.
Yeah. So Git doesn't delete the file. It is once it is struck, he doesn't delete it. You can recover that. But if you mean, for instance, the motion of the head pointer, then it can be explored in detail with the Git ref log. So it will be explored in the lecture, in the coming lecture. Yes. Is there any question? Another question? So I think you can try these initial commands. Then now we can start a break, right? When we come back, we will see additional commands for Git. So we are reconvening. Let me see. At 11:30, we reconvene. So previously we saw how to add one single file, right? Where we did some modifications. But in general, we have several files in our directory that we have modified and that we need to add, right? So will we be tedious to add one file at a time? And that's why Git support the Linux type wildcards, right? So, and what they are? So basically, they are symbols that can be replaced by different strings. So for instance, here, if we type the wildcard question mark, it means one character. So imagine that in your folder, you have 3 files called file1.txt, file2.txt, and file3.txt. So they will be added because there is only one character, yes, between file and .txt. So there is also a wildcard for the brackets, right? So, and here in the brackets, we can introduce some integer that goes from 0 to 9, or a letter that goes from A to Z in lowercase or in capitals. So you can use this wildcard for an integer or a letter only, right? And here it says add the files from file to from 1 to 3 and .txt. So this behavior will be the same in this case because we have only 3 files. But if we have more files up to 9, this command will add all the 9 files, but this one will add just the first 3. So there is a more general wildcard that is being accessed with the star character. And then in this case, it means 0 or any number of characters. For this particular case, star.txt, it means any string followed by the .txt. So it means in this case, it will add the 3 files, but if in our directory, we have also other files called, for instance, test.txt or any other name ending with .txt, then they will be added as well. So it's convenient, as I said, if we want to add multiple files at a time. But also be aware of this behavior. So maybe in your commit, you don't want to add all the files at the time, right? And if you type this will add all the files ending with .txt. So it depends on what you want to achieve. So there are also other shortcuts in Git, and they are more general. So if you want to add all the files, including those in the parent folder, right? And also in the subfolders, then you type -A capital, right? And if you want to add the files in the subfolders, then you type git add and the dot. So imagine that you have an existing file. In this case, we have the first .txt file in our repository, and we want to rename it to readme.txt. So there is a command called git mv that allows us to do it. We type git mv, the name of the file, in this case, first.txt, and we rename it to readme.txt. So it seems that there is no change at this point. And but if we look at the status of the repository, so we will see that there are some changes that can be committed. And in this case, it's just the renaming of the first .txt file that is now called this way. So we'll need to write a commit message in this case. So here there is only a recommendation that is also given in the book that I mentioned before, Git Course of Good. So it says that renaming the file instead of creating new ones is recommended because it can help you to keep a consistent history of the file, but also it depends on what you want to achieve, and it's up to you if you want to rename file or just delete them. So now we have this file that can be committed, and we can do it here, git commit, And I will write just a short message. Yep, and give the status will show us that nothing is being has to be committed, and also now the file is called readme.txt. So moving files around can be done with the mv command, similar to the Linux mv, right? And in this case, you can change the location of the file. For instance, if I have now a folder called src, I can create here a folder in Mac or in Linux. I have this command make mkdir, yes, that can create a folder, and in Windows, you can just do it with the mouse buttons, right? Create a folder, src, right? And then if I want to move the README file to the new location, I can type git mv readme, and then the name of the folder, src. Sorry, is src, no scr. Okay, now it seems that there is no effect when I type this git mv, but if I check the status, I can see again that something has been renamed. In this case, the file name was placed in another location, and this change is ready to be committed. So now I can also commit this message or this change, and I will call it rename or changing file location. Yeah. And now the status shows that there is nothing to be committed. In this case, you can move the files across the different folders that you have and keep track of the location of the files. So removing files is similar to Linux, right? With the rm command, but in Git, you need to use a git rm, so that Git is aware of the file deletion. So how does it work? Basically, you type git rm and the location of the file. Yeah. So in this case, we have only one file, which is the README file, and I want to delete it. So I can use the git rm, the src, and the README file. So it says rm and src README. So now I can check the status. And it says there are some changes to be committed. So, and there is a file deletion. right? So this is just a recommendation. It's more convenient to rename files instead of deleting them. But as I said before, it's up to you and up to your needs. So there is now this change to be committed, and I can type git commit -m, and I can say readme file deleted in src. So now my status is nothing on the branch to be committed. And now look at the content of this project. It's basically empty. So even the src folder is not present because once I delete the content of the folder, it is not there anymore, right? So this is a way to delete the folder as well. So that when the content is empty. So so in this way you can work with the files, right? You can create the files, rename the files, move the files around across the different folders, and the commands are basically similar to the ones in Linux, just that you need to add the git prefix before. So ignoring files. This is useful, especially when you are dealing with a software that generates temporary files or binary files. Temporary files, the issue can be that there are too many temporary files. For instance, imagine that you're tracking a LaTeX project. LaTeX is a program to compile text files, right? So that you can generate a render file in PDF, for instance, or PS. The binary files, the problem is that they are big in general, right? For instance, if you are compiling your code and you generate the executable file, temporary files can be many of them, right? And they are not useful for the final output, so you don't need them. And binary files can be just a few of them, but they are too big in size. So in general, you don't want to track all of this because they are just temporary files or files that are not useful for your code. So how can we ignore these files in our repository? There are some ways to ignore them, and one of them is by using the git ignore in your repository. And it follows similar rules as in the GitHub, as in the Linux operating system, by using the wildcards. So how can we do it? We can place a git ignore file as usual in our repository, and then we can add some rules and use the wildcards that I mentioned already. For instance, if we use the star wildcard followed by some string, it means any file that starts with any string and it ends with a .tmp file, or it starts with any string and then it ends with .bin file. So you can place this file in your repository and start tracking it, right? And then it will ignore the files. One caveat of using this git ignore file is that it will be shared with your collaborators. So, and this can be an issue if your collaborators need some of the files that you already ignored. So maybe one type of files ending with DAT are not useful for you, but they are useful for your colleague, right? And because this git ignore file will be shared, right? So then it will create some issue when you are using some rule, right? And your colleague doesn't need it. So how to avoid this situation with the git ignore file that is placed in your local repository? One way to do it is by using instead the git info exclude file. And one advantage of using this file here is that this file is not shared. It's present just in your local repository. So how does it work? So here I am sitting still in the repository that it was empty, right? So I will open the git info and exclude the file. So you see here that I have some comments, everything is starting with this dash, no, with this symbol here. I don't hash. The hash symbol is a comment, and the rules starts just when you don't write this hash symbol. So I will write a rule in my git info exclude file, and I will, for instance, write the following rule: everything that starts with some strings and end with the tmp suffix. Yeah. So I write only this rule here, any character and that ends with the .tmp. Then I will save this modification, right? And it's already there. So I check my status and nothing needs to be committed. And I will create a file called, for instance, test.tmp. You can use here your preferred editor. I am using now a Vim. So, and I will use here some string. This is a temporary file. And there could be many of them. Then I save this file, right? And now I check my status. and still it says nothing to commit, right? Nothing to commit, working in tree clean. So, but I can check now the content of the directory, and still I see the temporary file. So it means that the Git is ignoring this file, right? Why? Because I wrote the rule here in the info exclude file that this file should be ignored. So what about, for instance, if instead of calling it test.tmp, I call it test.dat, right? So notice here that I'm using mv because this file is still not tracked by Git, right? So I can use Git, I can use just mv as a plain Linux command. So now I have this file in my repository. It's called test.dat. And if I check the status, then you will see that Git is aware of this file here. Yeah. Okay. Now, so now I can go to, yes, yes, do you want to ask now? Yeah.
Yeah, so why should I use git ignore at all then? Because this seems to be way better option. Or
Yeah, but it is strongly depends on your community, because when you are working alone, you can decide the rules, right? But if you are working in some community that uses some git ignore, then yeah, so it strongly depends on the needs. But actually, yes, I would prefer this git exclude.
but do you commit the git ignore file?
Yeah, that's correct.
Okay.
You need to commit it.
Okay.
And once you commit it, it starts ignoring the files. And yes, and when we look at remotes later on in this course, you will see that this git ignore is sent to the public repository. And this will be obtained from your colleagues. So it will create some issue, for instance, if your colleagues want to track of some of these files and you ignore them. But I would prefer this git exclude because it's local. Okay, let me now go to the next command. So there are some aliases that can be used by Git, and they can help you a lot, right? And one of my favorite ones is the git log alias. And I showed you before that if you type git log, you will get some information about the commits. These are the so-called hashes. We will look at them tomorrow. And also some details and the commit message, right? So but sometimes this is a long or a very detailed information, and you don't need everything. So you can simply type git log -- all -- decorate, and on one line for typing one line only, and dash dash graph, right? So if you type this option here, then you will get some compressed information from the hashes, right? This sequence of letters here, and they are cut up to the to the seventh string, right? And this is all particular information from the commit messages. There's a compressed way to show or to display the commit tree. So, so about typing this long line is tedious, and if we need to do it every time, it's not that convenient. So you can create an alias, right? And for this particular command, you can type git config dash global alias graph. So this is the name that you want to give to your shortcut. Yes, in this case is graph. And here is where you include all the message that you want, right? So for instance, if I do it here, then the next time I can type git graph only, and it will display the content, right? With this command here. So it's a way to create the aliases that you want, especially when you have a long commands. So you have seen that several times I have typed git status, right? And some people write simply git st when they create some alias, because this git status is a command that is typed many times, right? So you can create your alias in this way. So it's how it looks. And the one possibility, right, instead of typing git graph, is by creating an alias, but this time in your bash rc file, and this is some way to do it. But in this case, you will type graph directly on the terminal and not git graph. Yeah. So it depends on you and how you feel comfortable, right? But these are two options. So now I can go to some so-called intermediate or advanced commands, and they are advanced in the sense that they are not very common, right? But they are useful, and they can help you in your flow, right? But they are not that common as the ones that I discussed previously. So imagine that you have some file. So you create the file, and I will call it here touch first.txt. Then I will add this file, and commit the file. Okay, now let me add some lines to this file. Okay. And then if I type the status, So you see that, okay, so you see that here is the file test first.txt that can be added. So I will remove, this test.dat that was added before for my previous example. And here you can see here the text, the first.txt. Yeah, this is the one I'm interested in right now. So now suppose that the new text, which has 5 lines, refers to different topics. Here I have one that refers to the to-do list, yes, and the other will refers to summary. And then you want to split this change into different commits. One that goes to a to-do list, and one that goes to summary, and they are split into different commits. How do I do that? So the main idea is that I can use git add by using the partial option, and is used with the dash p flag. So you do it. So git will tell you the different options, right? And I can choose the E to edit the file and open the editing mode. So then, because we don't want a summary in the first commit, we delete it. We delete that line and save the file. So we go to here. So we delete this file, this line, and save the file. Oops. Now it's, let me see, .e, edit, and remove. Sorry, is with dash, with a dash symbol. And we save the file. Oops. Yeah. Sorry. I will use the blank space. Interesting. Control X E, editing mode. Oh, interesting. Oh, interesting. This is not working. Let me see if there is a. Let me check the status. Okay, let me restore. So basically now we have modified the file and it's in the working directory. So I reverted these initial changes. Now I check the file and the lines that I want are there. So currently this file is in the working directory. Then I will try this again and see if this time it works for me. So go to the editing mode. Okay. Then I will delete this one and save this file. Let me see if it works. Interesting.
I think you need to delete the line above it as well.
Okay, let me. Interesting. I restore again. Let me see. Okay, now it's here. Interesting. Let me see. Okay. Yeah, now, thank you. Yes, and now let me see Git status. So you see that this here, the file is there. And what we achieved was the following. We put partial changes into the staging area, and there are also changes in the work directory. So now you see the different behavior that you can have with Git. So if you want to see the difference between the stash changes and the stash ones, you can use the Git diff. And here with the Git diff, you can see. So what are the difference? Yeah, right here, these are the changes that are staged, and this is the one that is only present in the working directory. Let's open this first file. And you see here that this one is present in the working in the working directory only. So the difference between the stash changes and the previous commit, so which means that the changes are in the local repository here, can be seen with the git diff -- stash and the git diff cached. These are the synonyms. So the difference between the unstaged changes and the previous commit can be seen with the git diff and the hit. And this is what is reflected in here and the unstaged. Let me see this one. between the unstaged changes in the working directory, and the previous commit in the local branch. So here between this one and this one. So you can take a look at the initial picture that I mentioned and see where the arrows are pointing for this case. So there is also another command that allows you to modify your last commit, but I included this into the advanced commands or intermediate, because as I said, they are not that common, and also some of these commands modify the history, right? So if these commits have been put in some public repository, it's not a good idea at all to use them, because then your colleagues will see that the history changed, and they would have to repair that by doing some merging or some other operations. So, but in your local repository for your local copy, you can use that to amend or to add more information to your commit. So if you want to include something else to your previous commit, you can use git commit -- amend, and there are some options like the -m that allows you to write some short message, or the -- no edit if you want to keep the message from the previous commit. So also we have seen this long command, right? Where we could create a shortcut for it, and we could use grid graph for that. So imagine that you have a series of commits from first to the fourth commit, and we want to simplify some of them because they are part of the same topic. For instance, if we want to simplify this fourth, 3, and second, as they belong to some special topic. So if you want to simplify the last 3 commits, we can use the git rebase command. This is a general command and very powerful, that can be used in several contexts. We will see that later on. But in this context, we want to simplify the last 3 commits into a single one. So if we type this, we will see these 3 options here, and we need to pick one commit that can be used as the base commit. So in this case, we use the second one as the commit where all the the other commits will be so-called squashed. So we pick the second, and then we squash the next commits, right? So in this case, we pick this one and write here, instead of pick, S, which stands for squash. And when we close this and save this commit message, we will see that all the commits are squashed into a single one. Now, when we try the git graph or the git log one-line command, we will see that we have one commit related to the 3 previous commits plus the first commit, right? So notice that here we modified the history, as you can see clearly here, and this is not a good idea for public branches. So the final command that we will look at is git blame, and here it's accessed with the git blame command. So if you write git blame and some file name, then you will see when this file was modified and who did it, the commit, the author, timestamp, line number, and other information, and then you can see who did the last modification and who who you can contact so that he could explain or give more information about that. So is there any question at this point? We are over time, so I think if there is no question, so let me see the document. So there is a question on the document. Any rules of thumb regarding how much title work to do before doing a commit? So that could change depending on the community where you are working on. But in general, for instance, if you're working, was a personal suggestion, so you are working on your local repository, then you can do so many commits, as many commits as you need, and then you can pack all these related commits into a single one, as I mentioned with the squashing option. But this is just in your local directory. I think it could be good if you track single changes, right? So that you don't lose any modification that you did to your code. But when working on public branches, this is another story, right? So maybe before sending your commits to the public branch, you can work on short commits, right? And then pack them into a larger one so that your colleagues don't see 20 commits related to just a single issue or topic. But also it depends on how your team is working. I think we are over time, so we can end it for today. So we can continue with the Q&A document, right?